So now that we kind of went through calculating forces, let's work on drawing free body diagrams and then work through a problem where we have more than one force. And we want to find what we call the resultant force. So that's what we're going to do in this video. So let's start with drawing a free body diagram. Basically what a free body diagram is it's a diagram of all of the forces acting on something. So it is all of the forces acting on something. So free body diagrams, they're great for word problems or really complicated problems because it allows you to get a simplified version of all of the forces acting on one thing. So here in this example, we have a hook on a wall, and there's two strings attached to this hook, and they're pulling on this hook, and force C is pulling with a force of 300 pounds, and force D is pulling with a force of 400 pounds. So I want to draw a free body diagram that has both of these forces on it. So my free body diagram, I have my hook that I'm just going to represent with a dot. Then I have my force C, which is equal to 300 pounds. And then I have my force D. So force D, which is equal to 400 pounds. So then I'm also going to draw in the angles because the angles are what's going to help me in solving this problem. So this is 60 degrees and this angle here is 30 degrees. So we have a 60-degree angle and a 30-degree angle. Okay, and then I also want to just draw in my x components of my force C and my y components of my force D, or x and y components of force C and x and y components of force D. So I'll draw those in with some different colors so you can see them a little bit better. So here is my y component, or my force C, y component. So forces C, y component. And then from here to here is my force C's x component. So this is my force of my y component and my force of my x component. We can see that this makes a triangle. So that's going to help us in solving for our x component and our y component. Same with force D. So here is my force D y component. And here is my force D x component. Again, it makes a triangle out of this bottom part, and we're going to use that to help us find the x and y component of D. Good, so let's start with force C, and let's start with solving for the x and y components. And let's just draw this picture, or this triangle, or I'm going to draw this triangle so you can see it a little bit better. So this is my force of C, and then I have these two components, my force CX and my force CY. And then this angle is 60 degrees. So that's just basically separating just force C so we can look at it a little bit more clear. Good. So we're going to dig into our triangle toolbox. We're going to pick which equation we want to use when we're solving for the x component of C. So this line right here, the x component of C. So this is adjacent to our angle. So we're going to use our ka of SOHCAHTOA. That means cosine theta is equal to adjacent divided by our hypotenuse. Adjacent divided by our hypotenuse. So we're using the ka of SOHCAHTOA. So we plug in that angle, 60 degrees is equal to adjacent, which is our FCX, our x component of force C. And then our hypotenuse is force C, which we know is 300 pounds. If we plug in cosine of 60 first and then multiply it by 300, we get our force C of x, or our force C, the x component, is equal to 150 pounds. 150 pounds. That's my x component of force C. If we look here, our x component is going in the positive x direction. So our final answer is positive. Now let's solve for our force C of y. So again, we're solving for y now. That's our opposite side from our angle. So we're going to use the SO, the sine theta equals opposite over hypotenuse of SOHCAHTOA, the SO of SOHCAHTOA. I plug in my angle of 60 degrees, so I have sine of 60 equals opposite. Opposite from my angle is FCY, or the force of C in the y direction, divided by my hypotenuse, which is my force of C, 300 pounds. Plug this all into a calculator, so I do the sine of 60 times 300 pounds, and I should get 259.8. So my force of CY equals 259.8 pounds. So I solve for my force of C in the x direction and my force of C in the y direction, and I got 259.8 pounds. My y direction force is in the positive y, so my final answer is positive. What I'm going to do is I'm going to go through and solve for the force of dx and the force of d in the y, or the force dy component. I want you to try these by yourself, and then if you are having trouble, you can watch through this part of the video. If you think you can do them on your own, try to do them on your own. Skip to where I have the answers in this video. Check your answers. If you don't have them right, back it up and watch how I do this part. Okay, so my force of D in the x direction. So again, I'll draw my picture here. This is my force D. Then I have force D in the x and force D in the y. The x component of force D and the y component of force D. And that is 30-degree angle right there. Good. So for force D in the x component, again it's adjacent to our angle, so we're going to use the ka of SOHCAHTOA. So we have cosine theta equals adjacent divided by hypotenuse. And then I plug in. So my angle now is 30 degrees, so the cosine of 30 degrees is equal to adjacent, which is FDX, the force of D in the x direction, divided by my hypotenuse. The hypotenuse is our force of D, which is 400 pounds. So divided by 400 pounds. If I plug that all into a calculator, I do the cosine of 30 times 400, I get 346.4 pounds. So my force of D in the x direction is 346.4 pounds. Then I do my force of D in the y direction. We look here, we're gonna do, it's our opposite side for my angle, so I'm gonna do the SO of SOHCAHTOA. So sine of theta equals opposite over hypotenuse. Theta is 30 degrees, so I do sine of 30 equals opposite, which is FDY. That's opposite of my angle, divided by my hypotenuse. Again, the force of D, 400 pounds. Plug that all into a calculator, and I get FDY equals 200 pounds. But my FDY is in the negative Y direction. It's going down. So this is negative 200 pounds. Negative 200 pounds because my FDY is in the negative Y direction. It's pointing down. Good. So now at this point, I've solved for my force of C in the X direction, my force of C in the Y direction, my force of D in the X direction, and my force of D in the Y direction. Now we want to know, what is the resultant force? If both of these forces are pulling on this hook, what is our overall force, and in what direction is it? So, to find the resultant force, what we do is we find the X component of our resultant force. Then we find the Y component of our resultant force. And then we use those to find our overall resultant force. So, Fx of our resultant force, R, is equal to Fcx plus our other force, Fdx. So I'm adding up all of the forces in the X direction that's acting on this to get my resultant X force, or my ending overall force in the X direction. So these two are going in the same direction. We know this is in the positive X direction, this is in the positive X direction. So if they're going in the same direction, we add. If they're going in different directions, we subtract. If they're going in the same direction, we add. If they're going in different directions, we subtract. So here, both my force of X, or my force C in the X direction and my force D in the X direction, they're both going in the positive X, so we're going to add them together. So I get 150 plus 346.4. I add those two together, and I get 496.4 pounds. 496.4 pounds. That's my Fx of my resultant force. We do the same thing for Fy, except we're going to use our Y components now. We're adding up all of the Y direction forces is what we're doing. So any force in the Y direction that's acting on this hook, we're going to add it together to get our final or our resultant overall Y force. So my Fy of my resultant force is equal to, these two are going in different directions. My Y force or my Y direction force for C is going up in the positive Y, and for D, it's going down in the negative Y direction. So we already have a negative number here. We're just going to subtract our positive number from our negative number. So we get Fcy technically plus FDY, but then when you plug in the negative, it makes it subtraction. So you have 259.8 minus 200 pounds. So you get my Fy of my resultant force, or my overall force in the y direction, is 59.8 pounds. It's positive. We had more force in the positive y direction with force C than we did in the negative y direction with force D. Okay, we're almost done. We're in the final home stretch. I know this is a long video. What we're going to do to find our resultant force, which is just the overall force, basically, is, let me draw a picture for us. So we have our force of X. So our force X of our resultant force in the positive X. Then we have our force Y of our resultant force in the positive Y. This is going to be our final resultant force here. So the way that we do that is we have a right triangle with our resultant force as the hypotenuse. So we're going to use Pythagorean's theorem. A squared plus B squared equals C squared. My force X squared plus my force Y squared equals my overall resultant force squared. My force X, 496.4 squared, plus my force Y is 59.8 squared equals my force resistance. And if we take the square root, it'll get rid of that squared for us. So if I square this first, square this second, then I add the two together and take the square root, I get my final resultant force is equal to 500 pounds. So we have to go through all of this work here to get this final resultant force of 500 pounds. And this is what I mean by we have to organize our work on these problems. If we do not set this up in an organized way, we will have no clue what any of these numbers mean when we're trying to use them later on. So you need to organize your work with setting up force C broken into the X and the Y, force D broken into X and Y. That way when you go to solve your resultant force, you know exactly what these numbers mean.